Bismillahirrahmanirrahim. I welcome class 10th in my lecture series for chemistry. In our today's lecture, we will study about the functional groups containing carbon, hydrogen and halogen. And we will also study about the organic compounds containing double and triple bond as the functional groups. So what are functional groups? We read about them in our previous lecture that these functional groups are an atom or a group of atoms that give a family of organic compounds its characteristic chemical and the physical properties. So in today's lecture we will study about three families of organic compounds having a certain functional group in them. So first we will study about the functional group containing carbon, hydrogen and halogens. So before studying about this class of compound, let's first discuss that what are halogens. Halogens are the group 7 elements. All the elements that are present in the group 7 of the periodic table are called as halogens. The word halogen means salt forming substances. Halogens are the substances that when reacts with metal results in the formation of wide range of salts. Therefore, they are called as the halogens. Now, since these halogens are the group 7 elements, so they form one bond. Example of halogens include fluorine, chlorine, bromine and iodine. Now let's suppose that if we draw the valence shell of fluorine atom, then in the valence shell 7 electrons are present. We have 3 pairs of non-bonding electron and we are left with one non-bonded electron. Now what fluorine does that it share this electron with any other atom to complete its octet. So this means that all the halogens can only form one bond. So haloalkanes are defined as the derivative of hydrocarbons containing halogen atoms. We have read about the derivatives of hydrocarbon, that these derivatives are the compounds that are formed when a hydrogen atom is removed from that hydrocarbon and is substituted by any other atom or the group of atoms. So in the haloalkanes, one hydrogen atom from the hydrocarbon is removed and gets replaced by the halogen atom. So haloalkanes are formed by substituting one hydrogen atom of an alkane by one halogen atom. For example, we have also read it before that we have an alkane that is methane. Now if we remove hydrogen atom from this alkane, it gets converted into methyl radical. Now this methyl radical and the chlorine react together to form methyl chloride. Now this methyl chloride is the derivative of methane. It is formed after the replacement of hydrogen atom with the chlorine atom. So haloalkanes can contain more than one type of halogen. For example, CFCs or the chlorofluorocarbons contain both chlorine and the fluorine atoms. Now this, you must have read about this chlorofluorocarbons, that they are used in the aerosol sprays, they are also used as refrigerants and they are very harmful for ozone, they cause ozone depletion. So these chlorofluorocarbons are basically the haloalkanes and they contain more than one kind of halogen in a single compound. For example, in this structure you may see that this compound is containing two types of halogen, fluorine and the chlorine. So an organic compound may contain one or two types or more than two types of halogen in a single class of compound related to haloalkanes. Chlorofluorocarbon is one of the example of the haloalkanes. The general formula for the haloalkanes is represented by Rx. Now these haloalkanes are also called as alkyl halides. Alkyl halides is another name for these haloalkanes. In this general formula, X represents the halogen group, that may be fluorine, chlorine, bromine or iodine. And the R is an alkyl group. We have read about the alkyl groups, how they are formed. They are formed by removing one hydrogen atom from that hydrocarbon. So for example, we have ethane and let's suppose chlorine. Now we want to make a haloalkane from these two substances. Then what would we do? We will first remove a hydrogen atom from this alkane. When a hydrogen atom will be removed, it will get converted into an alkyl group, or you may say alkyl radical. Now one of the chlorine atom gets attached with this carbon atom and it results in the formation of an alkyl halide or a haloalkane. This is called as ethyl chloride. So this portion is the alkyl group and this portion is the X group. So this is how haloalkanes are represented. So now you have to distinguish among the following, that which of the following molecules are haloalkanes. Now you may see here in the first example we are given methane. Now since none of the hydrogen atom has been substituted by any other functional group, so this means that it is a hydrocarbon. So it cannot be a haloalkane. Now let's move towards the second case. In the second case, you may easily see the presence of a halogen atom, that is chlorine. So therefore it is a haloalkane. In the third case, you may easily recognize the presence of another halogen atom, that is bromine. So bromomethane is also a haloalkane. In case of ethane, none of the hydrogen atom has been removed by any of the functional group. So therefore it is a hydrocarbon and not a haloalkane. It is an alkane. In the chloroethane, you may easily recognize the presence of the chlorine atom. So this is a haloalkane. Now let's move towards the organic compounds having double and the triple bond as the functional groups. We have read about the alkenes, that alkenes are the hydrocarbons that contain one or more carbon-carbon double bond. And the functional group is this, C double bond C. In the examples of alkenes, we read about ethene. Now the word eth means the prefix eth means that organic compound has two carbon atoms. The suffix ene means that organic compound is having double bond between two carbon atoms. So first we will draw C double bond C, and then we will complete the valency of each carbon atom. Now you know that each carbon atom forms 4 bonds. So for this carbon atom, we will draw two more bonds, and for this carbon atom we will also draw two more bonds in order to complete its valency. And a hydrogen atom will be attached at the end of each bond. So this is the structure for ethene, and ethene is an alkene. So all the organic compounds having C double bond C will be considered as alkene. Now for alkynes, we read that these are the hydrocarbons that contain one or more C-C triple bond. So the functional group in alkyne is C triple bond C. In the example of alkynes, the simplest case of alkyne is acetylene, now also called as ethylene. In ethylene, two carbon atoms are present. So there is a triple bond between two carbon atoms. So in order to complete the valency of each carbon atom, we will just draw one more bond. And if a hydrogen atom is attached at the end of each bond, then this is the structure for ethine. Now the presence of this C triple bond C classifies them in a class of organic compound that is alkyne. So which of the following is an alkene or alkyne? In the first example, you may see the presence of double bond, so therefore it is an alkene. In the second case, there is a triple bond between two carbon atoms, so therefore it is an alkyne. In the third example, you may easily see the presence of double bond between these two carbon atoms in the propene, so therefore it is an alkene. Now we have a question that are halogens functional groups? Can we consider halogen as a functional group? We know that in haloalkanes, the carbon atom is attached to halogen, and when they are attached to halogen, they get activated, and because of that activation, they are more likely to get involved in a chemical reaction. For example, we take the example of chloromethane. Now, if you see the electronegativity value for carbon and chlorine here, the electronegativity value for carbon is 2.55, whereas for chlorine it is 3.16. Now you may see here that this chlorine is more electronegative than carbon atom. Since it is more electronegative, so there would be partial negative charge on chlorine atom and partial positive charge on the carbon atom. Now because of this electronegativity, that CCl bond gets slightly polar, and because of the introduction of polarity, they become reactive. So therefore these halogens carrying organic compound show their own characteristic reactions. Means that these haloalkanes show their own chemical reactions that are limited to only those organic compounds that have halogen atoms in them. So on these two bases, we may classify we may consider halogen as a functional group. So all the organic compounds having halogen atoms are considered as alkyl halides. All these organic compounds are classified in the family of alkyl halides or the haloalkanes. Now we have another question. Which functional groups do not contain oxygen? If you have watched the video related to the functional group overview, then you may easily answer this question. In that video, out of all the functional groups that we have read, there were few groups that didn't contain the oxygen atom. What were those? First group that we read today is the halo group. That halo group means that either chlorine, bromine, iodine or fluorine atom is attached to the hydrocarbon. So these groups will be called as the halo group. Now you may see here that none of these group contain oxygen atom. Another group that do not contain oxygen atom is the amino group. For example, in these examples, in the methylamine, this presence of C single bond N is classifying them in the class of organic compounds considered as amines. Now in all these examples you may observe the presence of C single bond N, but since there is no oxygen atom, so therefore it is an example of that functional group which does not contain oxygen atom. So this was all for today. Thank you for being with me.